Hello children, we continue in this video with problems on matrices, determinants, vector algebra and 3D. First we start with the matrices and determinants. You are given the determinant value is equals to 5. Let's say this is a matrix determinant and delta is equals to B2C3 minus B3C2. Clearly you can see that B2C3 minus B3C2. Isn't it actually the cofactor of the element A1? And of course the remaining elements also, if you could observe this one, these are the actually in delta, the elements are nothing but the cofactors of the elements of A. In the sense that delta is nothing but actually the determinant of adjoint of A because it is a cofactors matrix. And you know this basic formula, this is det A to the power of n minus 1, where A is a matrix of order 3 by 3 and therefore 3 minus 1 whole square. So det A square. And you are given det A is equals to 5 itself and therefore 5 square. It is 25. So the answer for delta is equals to 25. Coming to second one. D is equals to the determinant 1 sine theta 1 minus sine theta 1 sine theta. Of course, so below the diagonal elements are negative. And what is the range of this determinant? Okay, let us see that the determinant is equals to 1 sine theta 1 minus sine theta 1 and sine theta minus 1 minus sine theta and 1. The determinant value when you expand, I hope you'll be getting 1 plus sine square theta minus sine theta multiply by, it is minus sine theta plus sine theta, it is 0, and plus 1 multiply by sine square theta plus 1. So clearly you could see that this is a 2 times of 1 plus sine square theta. We know from the basic trigonometry, sine square theta lies between 0, 1 and therefore 2 times of sine square, 1 plus sine square theta lies between 1 and 2 and therefore the determinant lies between 2 and 4 because it is twice of this value. So the range is equals to 2 to 4. That's answer. Coming to the next one, third one. If there are 3 square matrices A, B, C of the same order satisfying the condition that A square is equals to A inverse. And let B is A to the power of 2, A power 2 power n, C equals A power 2 power n minus 2, then determinant of B minus C. And of course, for any value of n also, this condition has to be satisfied. But as here C is equals A power 2 power n minus 2, I can take up n equals to 2 minimum. Then I will proceed. A square is equals to A inverse given. If I pre-multiply A both sides, A cube is equals to A multiplied by A inverse. That means A cube is equals to unit matrix. You are given B is equals to 2 to the power of A power 2 power n. So A power of 2 power n and B is equals to C. C is equals to A power 2 power n minus 2. Why can't you take out B minus A, B minus C for n is equals to 2? Let me take up for n equals to 2, B minus C equals to A power 4, you get it, because n is equals to 2 and minus 2 minus 2, 0, 2 power 0, 1, nothing but A, which is A multiplied by. In this one, why can't you take A common? This is A cube minus I, but A cube is equals to I, therefore it is a null matrix. So the determinant of B minus C is equals to 0. So the answer for this one is 0. Coming to next one. If A is a 4 by 4 matrix and Aij equals to 2 for the diagonal elements and 0 for non-diagonal elements, it means A matrix is given to you as 2 0 0 0 and 0 2 0 0 0 0 0 2 0 0 0 0 2. This is actually the scalar matrix, and of course determinant of from this one, determinant A is equals to 2 power 4. And you require to evaluate determinant of adjoint A by 7 and a fractional part of it. Okay, let me take up adjoint of adjoint A. Adjoint of adjoint A is det A to the power of n minus 1 whole square. But that is equals det A is 2 power 4 taken whole to the power of n minus 1 whole square. N is equals to 4 here, order 4 minus 1, 3 square is 9, 2 to the power of 36. And you are asked to calculate the fractional part when you divide it by 7. So therefore, let us try to express this number in terms of 7 as 2 cube whole to the power of 12 and 8 to the power of 12. This can be written as 1 plus 7 to the power of 12. By using binomial expansion of this one gives us 1 plus 7 times of k, because 7 multiple you get it one in a binomial expansion. Get it. And therefore, when you divide by 7, adjoint of A divided by 7 gives us 1 by 7 plus an integral value. So the fractional part of this particular number, it is equals to 1 by 7, fractional part of this one. And that is equals to 1 by 7 only. So the answer is equals to 1 by 7. So the next one. If P is orthogonal matrix and Q is equals to PA P transpose R is equals to, yes, of course, P transpose Q per 1000 P, then R inverse is how much? And A is involutory matrix. Of course, A is involutory, P is orthogonal matrix. P orthogonal means P transpose equals to P transpose P is equals to unit matrix. And A is involutory. A square is equals to unit matrix. A square is a unit matrix. Okay, now let me take up. You are given that Q is equals to PA P transpose. So PA P transpose. And R is equals to P transpose Q to the power of 1000 into P. Yes, of course. Let me take up this value. So when you take up Q square is equals to PA P transpose multiplied by PA P transpose. Of course, P transpose into P is equals to unit matrix. Therefore, PA square multiplied by P transpose. And therefore, the same way when you take up, Q power n. So, and that implies Q power n is equals to P into A power n into P transpose. And if I consider P transpose into Q power n into P, you will be getting P transpose into P, A power n into P transpose into P. That is equals to A power n. And therefore, now you got R is equals to P transpose Q power 1000 into P. So R is equals to P transpose Q power 1000 multiplied by P. That is nothing but A to the power of 1000 according to this one. And that is equals to A square to the power of 500. But A square is a unit matrix, and unit matrix to the power of any number is nothing but unit matrix. Therefore, R is a unit matrix. Inverse of R is inverse of unit matrix is nothing but unit matrix. So the answer for this one is a unit matrix. Is a B answer. Next, the elements of a matrix A of order 10 by 10 are defined as Aij is equals to omega to the power of I plus j, cube root of unity. Then trace of the matrix. Trace means is nothing but actually sum of the diagonal elements. Okay, let's see that. So trace of the matrix is equals to sigma Aii. I runs with 1 to 10 because the matrix is of order 10 by 10. And that is equals to, it is a sigma omega power I plus I runs from 1 to 10. That's nothing but sigma omega power 2I runs with 1 to 10. And expanding of this one, you'll be getting I square plus, omega square plus omega power 4 plus omega power 6, power 8, power 10, power 12, power 14, and 16, 18, and 20. Simplifying, this is omega square plus omega plus 1. And this is omega square plus omega plus 1. Because omega cube is equals to 1 concept, I am applying it. So omega square plus omega plus 1. And lastly, omega square retains as it is. But 1 plus omega square is always be 0. And therefore, this is 0, 0 and 0. And therefore, retains it as a omega square. So the answer is equals to omega square. So D option. Coming to the next one. If f of x is given to you as the determinant, then the limit extends to 0 f dash x by x. Yes, of course, f dash means nothing but the derivative of this function. When you are finding the derivative of a 3 by 3 determinant, you have to keep in mind, you have to apply the concept like in UVW concept. So it means first row derivative keeping the next two rows as it is plus, then second row derivative keeping first and last as it is, and third row derivative keeping the first two as it is. Likewise, we find the derivative. Let me take up x square x square 2x. I'll write here conveniently. So x square 2x. And sin x tan x sin 2x, sin x tan x sin 2x, and lastly cos x minus x cube 5x, cos x minus 5x cube minus x cube 5x. And when I take up the determinant of this one, so f dash of x is equals to the determinant. First row derivatives are 1, 2x and 2, and keeping this as it is sin x tan x sin 2x and cos x minus x cube and 5x plus second row derivative keeping the first and last as it is x square 2x, second row derivative cos x secant square x and 2 cos 2x, keeping the last row as it is cos x minus x cube and 5x. And lastly, third row derivative keeping the first two rows as it is x square 2x and sin x tan x and sin 2x, and the last row derivative minus sin x and a minus x cube derivative minus 3x square and 5x derivative is 5. And let me divide by x here, f dash x by x. When you divide by x, you have to divide the first one by x here divided by x. And first row divided by x, you'll be getting 1 here and x here and 2. Here also 1 and x and 2. Yes, of course, dividing by x. And now you take up the limit extending to 0. Limit extends to 0, f dash x divided by x gives us the answer as like this. The first one as extends to 0, and of course the middle row, this is 1 1 1 1 1 and 2. I think it is sin 2x 1 1 2. And the first row it is 1 0 2. Third row cos 0 1 0 and 0 plus, and the second determinant dividing by x, of course you got this value x equals 0 1 0 2 1 1 and 2 1 0 0. I think it is same determinant. And here the second row elements entirely it is 0, therefore the determinant is already 0. You need not worry about the third determinant. Excuse me. And this is twice the determinant expansion. We expand the determinant along the last row, and that gives us answer here. Last row. So we'll be getting 0 minus 2. Answer is equals to minus 4. So the value of this f dash x by x limit extends to 0 is equals to minus 4. D option. Coming to the next one. Determinant x to x square x 6 and x 6 is equals to an expression in terms of a, b, c, d, e, but you're asked to calculate 5a, 4b, 3c and 2d and e as the coefficients are 5, 4, 3, 2, and definitely you will be getting you multiply x on both sides, x here and x you multiply here, so that you will be getting x to the power of 5. The derivative of x power 5 is nothing but 5a, you will be getting coefficient. So likewise you proceed by multiplying x on both sides and simplifies it. Okay, so x multiply by ax to the power of 4 plus bx cube plus cx square plus d x plus e, and that is equals to x multiplied by the determinant. In the determinant, the first column you got x common, that x also you can take out the common, you'll be getting x square multiplied by. First column after taking x common, 1x1, 1x1, and the second column 2xx, and the third column x 6 and 6. And an expansion of this one will be getting ax to the power of 5 plus bx to the power of 4 plus cx cube plus dx square plus ex, and that is equals to, it is x square multiplied by, expansion of this one gives us like this. I think it is 1 multiplied by 0 minus 2 multiplied by 6x minus 6 and minus x plus x multiplied by x square minus x. And of course that on simplification gives us x square multiplied by minus 12x plus 12 plus x cube minus x square. And of course when you multiply x square here, you will be having x to the power of 5 minus x to the power of 4 and minus 12x cube plus 12x square. Of course, comparing both sides, you got a, b, c, d, e values, but at the same time, you can find the derivative and substitute x equals 1. So find the derivative both sides. 5ax to the power of 4 plus 4bx cube plus 3cx square plus 2dx plus e, that is equals to, and here 5x power 4 minus 4x cube minus 36x square plus 24 times of x. And now x is equals to 1 if you substitute. You'll be getting 5a plus 4b plus 3c plus 2d plus e, and that is equals to 5 minus 4 minus 36 plus 24. 24 plus 5, 29. 36 and 4, 40. When you subtract, I think you'll be getting minus 11. So answer is equals to minus 11. Yes, of course, the D option. Coming to the next ninth one. If the system of linear equations has a unique solution. Yes, when system has a unique solution means the determinant of A, coefficient matrix, should not be equal to 0. So, therefore, determinant of A can never be 0. Should not be 0 for a unique solution. So, why don't you take up determinant of A, which are the coefficients of x, y, z. So, first one, 1 x plus y plus z means 1, 1, 1. Determinant 1, 1, 1, you get it. And the second equation 1, 2, 3. 1, 2, 3. And the third one 2, 5 lambda. 2, 5 lambda. And that should not be equal to 0. Let me expand this one. So by using, expansion, 1 multiplied by 2 lambda minus 15 minus 1 multiplied by lambda minus 6 plus 1 multiplied by 5 minus 4, 1 equal to 0. And expanding 2 lambda minus 15 minus lambda plus 6 plus 1 is equal to 0. So it is lambda, 2 lambda minus lambda, lambda. 7 when you subtract, I think minus 8 not equal to 0. Yes, of course, so for a unique solution, data not equal to 0. Not 0, not 0, not 0. It is not 0. So therefore, lambda cannot be is equals to 8. So the answer for this one is lambda cannot be equal to 8 is answer. Option A. Coming to the next one, the determinant delta is equals to something which is divisible by. Generally, as it is a polynomial in x, of course, a, b, c are constants, definitely it is supposed to be divisible by either x square or x cube. We need to check which one is the correct answer, but definitely not a, definitely not a, b, c. So why not you take certain numbers, because this determinant is divisible by either x square or x cube, whatever be the a, b, c values then. So let me take up a equals to 1, b equals to 1, c equals to 1. So if you take up a equals to b is equals to c is equals to 1, then delta is equals to the determinant. You'll be getting it as 1 plus x, 1, 1, 1, 1 plus x, 1, 1, 1, 1 plus x. Yes, of course, 1 plus x, 1, 1, 1, 1 plus x, 1, and 1, 1, 1 plus x. And that determinant is equals to, it is 1 plus x multiplied by, it is 1 plus x taken whole square minus 1, of course, the first one, minus 1 multiplied by, it is 1 plus x minus 1, and plus 1 multiplied by, it is 1 minus 1 minus x. And of course, that is equals to 1 plus x taken whole cube minus 1 minus x, and this is minus x and minus x. When you expand this one, 1 plus x whole cube, so 1 plus 3x plus 3x square plus x cube minus 1 minus 3x. Minus 1 minus 3x gets cancelled. I think we'll be getting x square multiplied by 3 plus x. So it is a multiple of x square. So therefore it is divisible by x square only, not x cube. So the answer is equals to divisible by x square. Right? Coming to the next one. The absolute value of the sum of the roots of this equation. Absolute value of the sum of the roots of this equation. Hope we have to simplify this determinant. We need to simplify it, okay, by subtracting it. Let me take up R2 minus R1. Subtracting R1 elements from R2, you'll be getting first row as it is you put up. Okay, R2 you change like R2 minus R1. R3 also change, subtracting it. Of course, I think it is better you subtract R3 first. Yes. So therefore, we'll be writing R3 subtract from R2, and then later you change R2 like R2 minus R1. Thereby delta is equals to the determinant. Keeping the first row as it is, x plus 2, 2x plus 3, 3x plus 4. X plus 2, 2x plus 3, and 3x plus 4. 3x plus 4. Second one, x plus 2 plus 3. Yes, of course. 3x plus 5 minus 2x plus 3. Last row will be giving us x plus 2. This is x plus 2. And 5x minus 2x. I think it is 2x plus 4. 2x plus 4. And the next one, 10 minus 4. It is 6. 6x plus 12. Yeah, 6x plus 12. Next, R2 minus R1, x plus 1. And this also x plus 1 and x plus 1. Yes, of course, it is x plus 1 and also x plus 1. And that determinant is equal to 0. And that implies you can have x plus 1 common factor and x plus 2 also common factor. Determinant x plus 2, x plus 2x plus 3, 3x plus 4. And 1, 1, 1 and 1, 2, 6. Determinant is equal to 0. An expansion of this one. Let me keep this as it is. An expansion of this determinant is x plus 2 multiplied by 6 minus 2, 4. Minus 2x plus 3. Multiply by 6 minus 1, 5. And plus 3x plus 4 multiply by. It is 2 minus 1, 1 is equal to 0. Whole thing is just multiply by x plus 1 into x plus 2. Into x plus 2. And of course, simplifying this one, we'll be getting it as a 4x plus 8 minus 10x minus 15 plus 3x plus 4. I'm just keeping expression as it is. And 4 plus 3, 7 minus 3x, you get it. 8 plus 4, 12 when you subtract minus 3, minus 3. So overall, you are getting it as here minus 3 into x plus 1. Already one x plus 1 factor has come. So x plus 1 whole square multiplied by x plus 2 is equal to 0. The roots are nothing but minus 1, minus 1, minus 2. Sum of these roots is equals to minus 4. So the answer is equals to minus 4 is a sum. But absolute value of the sum is equals to plus 4. Yes, of course. So the answer is equals to plus 4. Coming to the next one, the determinant d1 is equals to d1 by d2 you need to calculate. If you closely observe this one from the first column, And the last second column, if you add and subtract, d1 would be changing it, retains a plus b gets cancelled, c plus d gets cancelled, but here a minus b minus a minus b minus 2b get it. So the d1 is equals to, the determinant is nothing but a, yes of course ACA. Applying the concept C3, I am changing it to C3 minus of C2 plus C1. Adding the first two columns and then subtracting it. A plus B subtracting A plus B will be 0. Of course, second column B, D, B. So B, D and B. And therefore subtracting A plus B minus A plus B 0. Second one is also 0. A minus B minus A minus B. Yes, of course, I hope A gets cancelled, minus 2B. And that is equal to an expansion of minus 2b multiplied by AD minus BC. Of course, this is the D1. In the same lines, when you take up D2, same operation can apply. C3 minus C1 plus C2. A plus C cancel, B plus D cancel, A plus C also cancel, retains B. Of course, ABA, CDC, CDC, and this gives us answer B. And that equals to B multiplied by AD minus BC. And the ratio of this one, D1 by D2 is equals to minus 2. Modulus of this is equals to plus 2. So the answer is equals to plus 2. Yes, of course, the answer is 2. Coming to the next 13th one. Let S be the set which contains all possible values of Lmn and PQR for which the matrix is non-singular. Non-singular idempotent. Non-singular means determinant is not equal to 0. Yes, of course, non-singular det A not equal to 0 means A inverse exists. And at the same time, it is idempotent. Idempotent means A square is equal to A. Why not to multiply A inverse both sides? Into A square is equals to A inverse into A, and that gives us A is identity matrix. Are you sure? Yes, identity matrix. A is identity means the diagonal elements are each one is equals to 1. Therefore, L square minus 3. L square minus 3 is equals to 1, and M square minus 8 is equals to 1, and N square minus 15 is equals to 1. N square minus 15 is equals to 1, and the remaining elements has to be 0. P, Q, R must be 0. So P is equal to Q is equal to R equals 0 because it is unit matrix. And of course, L value plus R minus 2, you get it. M is equals to plus R minus 3. N is equals to plus R minus 4, you get it. And the sum of all values will be plus minus signs gets cancelled. Answer is equal to 0. Sum of all these possible values is equals to 0. So the answer is 0. Let's proceed. The next one. The matrix is given to you is an idempotent matrix. Idempotent means A square is equals to A matrix. A square is equals to A matrix. As A square is equals to A, determinant of A square is equals to det A. Of course, this is nothing but det A multiplied by det A minus 1 is equals to 0. Definitely, det A cannot be is equals to 0. So I can take up det A is equals to 1 now. So if I take det A equals to 0, ABC 1 minus A. ABC 1 minus A, determinant is equals to 1. That implies A minus A square minus BC, that must be equals to, determinant is equals to 1. Of course, but BC is given to you as 1 by 4. Det A is equals to, it is a non-singular because A is idempotent matrix. Okay, let us see that. Because it is an idempotent matrix, and therefore we say that A square idempotent means A square is equals to A. Okay, determinant of A is equals to 1, or det A is equals to 0 also you can take up. Det A is equals to 0. Of course, BC is equals to 1 by 4. So one choice, let me take up, yes, there are two choices if I take up det A is equals to 1. So therefore, we say that this is A square minus A. According to the function, f of x is equals to x square minus 2. f of x is equals to x minus x square, and therefore this is f of a. F of a is equals to bc is 1 by 4 plus 1, that is nothing but 5 by 4. You don't be getting 1 by f of a is equals to 4 by 5. So if I take up det a is equals to 1, suppose det a is equals to 0, then in that particular case determinant of a b c 1 minus a is equals 0. That implies so a minus a square minus bc is equals 0. So therefore a minus a square is equals to bc. That implies f of a is equals to 1 by 4. So obviously 1 by f of a is equals to plus 4. So of course the answer is equals to either 4 by 5 or 4. So clearly you could see that 4 is answer existing. So the answer is equals to D. Okay. Now let me take up P is equals to the matrix. You are given the P matrix. Aij, if it is of order 3 by 3, and Q is equals to Bij, and where elements of Q are given to you as, of course, the determinant of P is equals to 2. Det P is equals to 2. And determinant of the Q matrix you need to calculate, where Bij is equals to 2 to the power of. So, okay, let me take up Dij is equals to 2 power I plus j multiplied by Aij. So for all I comma j, this is a formula for the Bij constructions, and therefore we can say that the matrix Q is written it as nothing but 1 and 1. When you add, you'll be getting 2 square A11, 2 cube A12, 2 power 4 A13, and 2 cube A21, and 2 power 4 A22, 2 power 5 A23, and 2 power 4 A31, and 2 power 5, so A32, and 2 power 6 A33. So why don't you take out, and we would like to calculate the determinant of this one. So determinant of this equals to determinant of this one. Being it is a determinant, I can have a common values over here. The determinant of Q can be written as first row, why don't you take 2 square minimum common. From the second row 2 cube, and from the third row 2 power 4. Common if you take out, then what else remaining? A11, 2, A12. I hope you'll be getting 2 square A13. In the same lines, A2 cube when you take up common, A21, 2 times A2, 2, and 2 square times A23. And A31, 2 times A23, and 2 square times A32, 3. And from the second column 2 common, third column 2 square common. Therefore, you will be getting 2 square into 2 cube into 2 power 4 multiply 2 from the second column. From the third column 2 square multiply by determinant of P. But you are given already determinant of P is 2. So therefore 2 to the power of, it is again replaced by 2. So 2. Yes, of course, then what will be the sum of the powers will be getting? 2 plus 3, 5 plus 4, 9. 9 plus 1, 10 plus 3, 13 you get it. So 2 power 13. So the answer is equals to 2 power 13. So that's about a few points related with the determinant of, matrices and determinants. Now we shall start with the problems on the vectors. The first one, you are given R vector and 2R vector in terms of P comma Q. Okay. R vector in terms of P comma Q are given to you, and option wise if you can see that one, R and Q relation we need to calculate, eliminate P. Let us eliminate P. So R is equals to 3P plus 4Q. R is equals to 3P plus 4Q, and 2R is equals to P minus 3Q. 2R is equals to 3P P minus 3Q. Yes, of course, it is P minus 3Q. So let us eliminate P by multiplying the second equation by 2. So you'll be getting, so let's keep this one as it is R is equals to 3P plus 4Q. And the second one you multiply by 3, you'll be getting 6R is equals to, it is a 3P minus 9Q. Subtracting it to minus 5R is equals to, so 5 times 15 times 13 times Q. So therefore, R is equals to minus 13 by 5 times of Q, and the negative sign indicates that both R and Q are in opposite sign. If R is in one direction, then Q will be in the other direction. No doubt they are parallel vectors, but they are unlike vectors. They are unlike vectors. So that's one thing. They are in opposite in direction. At the same time, magnitude of R is equals to, it is 13 by 5 times modulus of Q. Definitely it is greater than twice of modulus of Q. 2 times modulus Q. So the answer for this problem is R is greater than 2Q. This is answer, and in the opposite direction, same direction is not possible. So answer is equals to B. Next, coming to the second one. A vector of magnitude 3 root 6 along the bisector of angle between 4 minus 7 4 and 1 2 minus 2. 4 minus 7 4. One vector is 4 minus 7 4. The other vector is, what is it? 1 2 minus 2. So 1 2 minus 2. Okay, we need to calculate a vector along the internal angle bisector, which is of magnitude 3 root 6. Okay, let me calculate that. And if you can assume that this is a vector and this is a B vector, and vector of this magnitude is nothing but 3 root 6 into A cap plus B cap divided by modulus of A cap plus B cap will be the answer. Okay, let me calculate first A cap. So what is A cap? I hope you'll be getting unit vector, the magnitude 16 plus 16, 32. Yes, of course, 32 plus 49. How much you'll be getting? 81 means 9. So unit vector is nothing but a 4 minus 7, 4 by 9. Okay, plus B vector. Yes, B cap is equals to 1, 2 minus 2 by 3, of course. And now A cap plus B cap, and that is equals to, and of course multiply 3 plus 4 7, you get it. 2 3s are 6 minus 7 minus 1, and 2 3s minus 6 plus 4 minus 2, and by 9 about this one. And the magnitude of this one means definitely modulus of A cap plus B cap, and that is equals to dividing by 7. Magnitude of 7 means 49 plus 1 plus 4. Okay, 54. Root 54. Root 54 means 3. Okay, 3 root 6, of course. This is of the magnitude 3 root 6. By 9 gets cancelled. I hope you'll be getting 7 minus 1 minus 2 divided by, okay, this magnitude only, no? Magnitude is 3 root 6. And the value of a required vector along the internal angle bisector 3 root 6 into A cap plus B cap by modulus of A cap plus B cap. That equals to 3 root 6 multiplied by A cap plus B cap. I hope we'll be getting 3 root 6. 7 minus 1 minus 2 divided by 3 root 6. These two gets cancelled. The answer is equals to 7 minus 1 minus 2. 7 minus 1 minus 2, I think it is the first option. Yes. Correct. Coming to the next one, third one. ABC form a left-handed orthogonal system. Then left-handed orthogonal system, A dot A4, B dot B9, C dot C is equal to 16. ABC scalar triple product. The scalar triple product ABC, I would take up a square of it, which is nothing but actually, you know, A dot A dot B, A dot C. Of course, B dot A, B dot B, and B dot C. Similarly, the third one. But as it is orthogonal system, and A dot B, A dot C, B dot A, and B dot C, all the values are zeros except the diagonal elements. Diagonal elements A dot A4, B dot B9, C dot C 16. 4, 9, 16, other elements are zeros. Okay, this is the product of these diagonal elements. And the magnitude of ABC value is nothing but 2 into 3 multiplied by 4. I think it is 24. So you require to calculate. But it is the modulus. Of course, when you take up square root, you'll be getting plus or minus 24. But as it is left-handed system, and therefore the box product of ABC has to be minus 24 is the right answer. Because of left-handed system, minus 24. Correct. Coming to the next one, you are given, yes, AB are unit vectors means modulus A is equals to 1, modulus B is also equals to 1. Of course, and unit vectors such that A dot B 0. A dot B 0 means they are orthogonal vectors. Yes. And C is given to you XA plus YB plus Z times A cross B. So C vector is equals to XA plus YB plus Z times A cross B. Why don't you take now dot product with A both sides? When I take up dot product, A dot A will become 1 because of unit vector X multiplied by 1. A dot B is already 0. And A cross B is always be perpendicular to. A cross B is perpendicular to not only A but also perpendicular to B. So dot product is 0. So X is nothing but C dot A. And therefore, C dot B similarly will be getting Y. C dot A cross B is equals to Z get it. So X plus Y plus Z is nothing but C dot of A plus B plus A cross B. A plus B plus A cross B dot C. X plus Y plus Z. Yes, answer. Coming to the next one, a parallelogram is constructed on the vectors. Yes, A is A and B, and if alpha beta are the magnitudes 2 each and angle between them is pi by 3 and the angle, then the length of the diagonal of the parallelogram. No, A, B are in terms of this 3 alpha minus beta. So of course this is a parallelogram with A comma B. Of course, A is equals to 3 alpha minus beta and B is equals to alpha plus 3 beta, alpha plus 3 beta, and alpha beta, both of them are magnitude 2 and angle between alpha beta is pi by 3. Okay, let me take up. And you require to find out the length of the diagonal of the parallelogram. One diagonal is equals to B plus A, another diagonal is B minus A. So B plus A addition is equals to 4 alpha plus 2 beta. And B minus A is equals to, so B minus A means minus 2 alpha plus 4 beta. And the magnitude of this one, definitely smaller one is B minus A because the values when you take up 4 root 5, 4 root 3, 4 and 4 root 2. 4, 2 2s are 4, 4 4s are 16 multiplied by 2 into 2. Yes, it's a bigger number. So I may guess B minus A would be the value which is the diagonal requirement. Modulus of this is under root alpha. So minus 2 alpha plus 4 beta taken whole square of it. That is equals to under root 4 alpha square plus 16 beta square and minus 2 2s are 4, 4s are 16 times alpha dot beta. So that is equals to alpha square is equals to 4 under root of 16 plus 16 multiplied by, yes, of course, 464 and minus 16 times modulus of alpha modulus beta into cos of angle between them is 2. Cancellation, I think 16 taken outside will be getting 4 root 1 plus 4 minus 16 taken out will be getting 2. Of course, 5 minus 2, 3. So 4 root 3. So the answer for the diagonal is equals to 4 root 3. B is answered. Yes. The next one. 3 vectors I cross I plus j, j plus k, k plus I taken 2 at a time form 3 planes. Taken 2 at a time. Yes, of course, 2. And let us consider 3 normals to this one. The unit vectors drawn perpendicular to these planes, unit vectors, so form a parallelepiped. That means you need the vectors which are normal to the planes which are formed by 2 vectors. Okay, ij, jk, ki. Okay, let me take up ij. That's nothing but ones. Yes, the first one is 1 1 0. Second one is jk, that is 1 0 1 1. Third one is 1 0 1. The cross product of the first one will be a normal to the plane containing the first 2. Yes, the plane constructed by the first 2, whose normal is given by the cross product of the first one. The cross product of the first vector, let me name it as A, and that vector is given by, I hope you'll be getting 1 minus 0. I'll be getting 1, second one 0 minus 1, third one 0 minus 1. 1 minus 0. Yes, of course. The second vector will be given by the next two. So 1 minus 0, 1, and 1 minus 0, 1, 0 minus 1. And C is equals to first and last, taken in the reverse order. Of course, 1, 0, 1, 1, 1, 0, the cross product, 0 minus 1. Yes, of course, 1 minus 0 and 1 minus 0. Yes, of course. Let me take up the first one, 1 minus 0, 1, and of course 0 minus 1. I think it is 1. Yes, of course. These are actually the normals of the planes. These are nothing but the normals of the planes. And the planes are formed by taken 2 at a time. That means this is a normal to the plane constructed by the first two, and this is the normal to the plane constructed by next two, and this is the actually the normal to the plane constructed by A and C. Okay, these are the vectors, let's say that, and these are the normals, and we are asked to calculate what is called the unit vectors. The unit vectors drawn perpendicular to these planes form a parallelepiped with a volume. Yes, and unit vector in this A cap is equals to 1 by root 3 times of this vector. And B cap is equals to 1 by root 3 times of this. B cap equals to 1 by root 3 times of this one. And the volume formed by these is given by A cap, B cap, C cap is equals to, it is 1 by root 3, you'll be getting 3 root 3 times of 1 minus 1, 1, and 1, 1 minus 1, minus 1, 1, 1, determinant magnitude of it. That is equals to 1 by 3 root 3 times. And unsimplifying this value, I think you can add up the last row to the first to second, you'll be getting 0, 2, 0, 2, 0, minus 1, 1, and 1, and expanding this one, you will be getting minus 1 into 0, minus 4. So 4 by 3 root 3. But that value is given to you as lambda by 3 root 3. And that is equals to lambda by 3 root 3. So lambda is equals to 4. So answer for this problem is equals to 4 answer. Coming to the next one. The value of A for which the 3 points are collinear. The value of A for which the 3 points are collinear. Yes, of course, the DRs must be proportional. 8 minus 7A, 8 minus 7A, the first one. Second one, 5 to 4. Third one, 6 minus 1, 2. 6 minus 1, 2. And these points are collinear. Yes, these points are collinear means A, B, C. The DRs of AB, x2 minus x1 minus 3, y2 minus y1, I hope you'll be getting 9, z2 minus z1 means 4 minus A, must be proportional to AC. I mean AC DRs are 6 minus 8 minus 2. Okay, that must be is equals to I think you'll be getting minus 1 minus of minus 1 minus of minus 7 plus 6, and that is equals to divided by 2 minus A. And of course 4 minus A divided by 2 minus A must be equals to 3 by 2. Cross multiplying, I hope you'll be getting. So 8 minus 2A is equals to 6 minus 3A. Bring it left hand side, A is equals to minus 2. So the answer A is equals to minus 2. Fourth option. Coming to the next one. ABC are 3 unit vectors. Each is inclined at an angle pi by 3 with each other, then the value of ABC. Okay, each one. ABC are unit vectors. Modulus of A is equals to 1, modulus B is equals to 1, modulus C is equals to 1. And A dot B is equals to modulus A, modulus B, cos of angle between them, that is equals to, it is 1 by 2. Similarly, B dot C is equals to 1 by 2, C dot A is equals to 1 by 2, etc. And you require to calculate A, B, C. Let me take up whole square of it. A dot A dot B, A dot C. And so on the values. When you take up, there'll be 1, half, half, 1, half, 1, half, and half, 1 negative. So why don't you take out 2 common from each of the value. So 1 by 2, 1 by 2, 1 by 2. I shall write here the determinant value is equals to. So that is equals to 1 by 8 times 2, 1, 1, 1, 2, 1, 1, 1, 2. That equals to 1 by 8 times of this, an expansion gives us 4 value 1 by 2. So clearly you could see that the value of A, B, C, I have calculated ABC whole square, am I right? So this you got it as a ABC whole square is equals to 1 by 2 means 1 by root 2 is required answer. So ABC equals 1 by root 2. That's right. Coming to the next one. ABC are unit vectors and B dot C minus 3 by 4 A cross C is equals to 2 times of A cross B. So A cross C is equals to 2 times A cross B. And you need to calculate actually C minus 2B. So C and 2B. So why don't you bring it left hand side? A cross C minus A cross of 2B. Because it is a scalar, you can just multiply to this one, you'll be getting a null vector. And therefore it is A cross of C minus 2B is equals to 0. So therefore the cross product of two vectors 0 means these two are parallel. It means C minus 2B is parallel to A. That means a scalar multiple of A. It is a scalar multiple of A, and therefore the modulus of C minus 2B is equals to. Modulus of C minus 2B is equals to modulus lambda into modulus A. But modulus of A is equals to 1. Enough if you calculate what is modulus of lambda. So how do you get this modulus of lambda value? So C minus 2B, modulus of C minus 2B, because you got a B dot C minus 3 by 4 modulus C modulus B given to you. Let me evaluate C minus 2B modulus. That is equals under root C square plus 4B square and minus 4 times B dot C. And that is equals to C square. So C magnitude is 3, you will be getting 9, and B is equals to 1, therefore will be getting plus 4 minus B dot C minus 3 by 4. So 4 gets cancelled plus 3. 7 means it is a 16, that is equals to 4. So obviously this lambda value is equals to 4, you are getting it. So the answer is equals to 4. Let me evaluate the next one. DEF are the midpoints of the sides. DEF are the midpoints of the sides of the triangle BCCAAB. Then AD plus 2/3 BE 1/3 of CF. In the case of the triangle, so A, B, C. This is D, E is the midpoint of C, AC, and F is the midpoint of AB. Yes, of course. At the midpoints, you are asked to calculate AD vector plus 2/3 of BE plus 1/3 of CF. So 1/3 of CF. Why don't you express them in terms of the midpoints? You know, D is nothing but AD means D minus A. D is the midpoint of BC. Can I write B plus C by 2 is D minus A, and plus 2/3 of E minus B. So E is a midpoint. A plus C by 2. Yes, of course, minus B. Plus 1 by 3 times F. So A plus B by 2 minus C. So why don't you take 1 by 6 common? Yes, of course, 1 by 6 times you'll be getting, 3 times. 1 by 6 means 3B plus 3C minus 6A. And since your CC gets cancelled, be getting 2 times plus 2A plus 2C, and 2 by 3 times means 3 taken, so 4B minus 4B, and of course 6 times plus A plus B plus A plus B and minus 2C. And that simplification, it is 1 by 6 times. Clearly, you could see that A value, so B and C. So let's see that 3B minus 4B plus B. So I think B gets cancelled entirely. What else remaining? C value. Let us see that 3C and 2C, 5. Of course, 2C gets cancelled. It is 3C, you get it. And how about A then? Minus 6 plus 3 minus 3. And that is equals to half of AC. So the answer is half of AC. Yes, answer is half of AC. That's it. Coming to 11th one. U, V, W are the vectors such that modulus of U equals to 1 and V is equals to 2, W is equals to 3. So U is 1, modulus V is equals to 2, modulus W is equals to 3. Unit vectors. Projection of V along U. Projection of V along U means V dot U by modulus of U should is equals to that of W along U. Projection of W along U. Projection of W along U, modulus of U. Projection of W. Projection of V along U is equals to that of W along U. And vectors VW are perpendicular to each other. V and W are perpendicular means dot product is 0. Then modulus of U minus V plus W. Modulus of U minus V plus W. And can I take up U minus VW whole square? And here modulus of U gets cancelled. Square of this one, A minus B plus C whole square is nothing but actually U square plus V square plus W square. Magnitudes are given to you, can substitute. Minus 2A dot B, U dot V, minus 2 V dot W and plus 2 times U dot W. Okay, U square is equals to 1, V square is 4 and W square is 9. And V dot W, yes, of course, this is equals to 0. And of course, you are given from here, V dot U is equals to W dot U. And therefore, these two also gets cancelled, plus 0. So 9 plus 1, 10 plus 4, 14. And therefore, the magnitude is equals to root 14 is the required answer. So the answer is equals to root 14. Coming to next one. If A comma B are any two vectors, A comma B are any two vectors of magnitude 2 comma 3. So magnitude of A is equals to 2, magnitude of B is equals to 3. Two vectors 2 comma 3, 2 times A cross B modulus 3 times A dot B. So 2 times A cross B modulus 3 times of A dot B modulus. 3 times A dot B modulus is equals to K. And you're asked to calculate the maximum value of this one, K. The maximum value of K. Yes, of course, according to the basic formula, this is, if theta is angle between A comma B, can I say this is nothing but mod A mod B cos sine theta? Modulus of A is nothing but 2 modulus B 3 multiplied by sine theta, being it is a modulus sine. And plus, and 3 times mod A mod B into cos of angle between them is equals to K. Yes, of course, this value we have 6 and 6 when you take out common, and therefore 2 sine theta plus 3 cos theta is equals to K by 6. And of course, you know the minimum value, the maximum value is equals to root of A square plus B square. So this will be K square. So K by 6 is less than or equals to root of 4 plus 9. So the answer is equals to 6 root 13. 6 root 13 will be the maximum value. Coming to the next one. A, B are the vectors such that A plus B is equals to root 29. So you are given A plus B magnitude is equals to root 29. Let us work out carefully. A cross one vector equals to the same vector cross B are given to you. Then the possible value of A plus B dot another vector is how much? Okay, I assume that this is a C vector. C is nothing but 2, 3, 4. A cross C. Okay, C vector is equals to 2, 3, 4. Okay, A cross C is equals to C cross B is given to you. And n possible values. So why don't you rewrite this one? A cross C, can I write minus of B cross C? And bring it left hand side and take in common A plus B cross product with the C is a null vector. Once it is a null vector, clearly we could see that both of them are parallel, and therefore I say that C vector is a parallel to this one, and therefore modulus, yes, of course, A plus B is equals to lambda times of C. Modulus of A plus B is equals to modulus lambda modulus of C. So magnitude. But the magnitude of C from here is equals to how much? Under root of 4 plus 9 plus 16 now. 29, root 29. Let's keep that one. And of course, modulus of A plus B is also root 29. This also root 29. Therefore, that implies lambda is equals to 1 is the data. Of course, truly speaking, plus or minus 1, I am taking the modulus value is equals to plus 1. And therefore, we require to calculate now A plus B dot product with A plus B is 1. Of course, 1 into C, without loss of generality, I would take it as lambda is equals to 1. I say that nothing but C vector, that is equals to 2, 3, 4. Now the dot product with this vector, A plus B dot minus 7, 2, 3. So A plus B dot product with minus 7, 2, 3. Minus 7, 2, 3. And that is equals to, how much you get it? 2, 3, 4 dot product with minus 7, 2, 3. That is equals to minus 14 plus 6 plus 12, 18, and you get to answer 4. So answer is 4. Yes. Coming to the next one. You are given ABC vectors and you're asked to calculate the values of alpha, beta, gamma with respect to condition. A cross B cross C. Let me evaluate. A is equals to 2, 1, 1. You are given that A is equals to 2, 1, 1. B is equals to 1, 2, 2. And C is equals to 1, 1, 2. Okay. And you're asked to calculate A cross B cross C. So therefore, A cross B cross C is actually A dot C multiplied by B minus A dot B into C. A dot B into C. A dot C means I think it is 2 plus 1, 3 plus, 2 plus 1, 3 plus 2. 3 plus 2, 5. Yes, of course, it is 5 times. 5 times B vector 1, 2, 2 minus A dot B. How much will be getting? 2 plus 2 plus 2. I think we'll be getting 6 times of C vector 1, 1, 2. Obviously 5 minus 6, I hope we'll be getting minus 1, and 10 minus 6, 4, and 10 minus 12 minus 2. Minus 1, 4, minus 2. So that you compare with the corresponding values of left hand side. So 1 plus alpha into I, of course, and 1 plus alpha into beta. So the first one, 1 plus alpha is equals to minus, and alpha is equals to minus 2. Beta multiplied by 1 plus alpha is equals to 4. 1 plus alpha minus 1 means beta is equals to minus 4. Alpha minus 2, beta minus 4. Yes, minus 2, minus 4. Options might be, yes, of course, the first option. Yes, only first option is answer here. So therefore, the answer is equals to A. Yes. You can also calculate gamma, but of course, you got answer here, the distinct answer. So you can say answer for this one. And you need to calculate now the unit vector is orthogonal to the vector and is coplanar with the two vectors. You are required to calculate a vector which is orthogonal to this one and also coplanar with these two. So it means the required vector is coplanar with these two means definitely that required vector will be, yes, coplanar with this means which will be perpendicular to the cross product of the next two. So therefore, a required vector is a perpendicular to 3, 2, 6. 3, 2, 6 perpendicular to this one. At the same time 2, 1, 1, 2, 1, 1 and 1 minus 1, 1. The cross product is given by, of course, you know how to take up the cross product. I think 1, so it is 1 minus of minus 1. So 1 minus of minus 1, it is a 2. And of course, so 1 minus 2 minus 1 and minus 2 minus 1 minus 3. This is 2 minus 1 minus 3 is a vector which is normal to these two vectors. Normal to these two vectors. So required vector should be perpendicular to 2 minus 1 minus 3. At the same time, orthogonal to this one. So what is a vector which is a perpendicular to these two? That means definitely vector perpendicular to these two, isn't it cross product of these two? Let me check that one. So you will be getting the cross product of these two, a perpendicular to these two. So I hope you'll be getting minus 6 and plus 6. So 2 3s are minus 6 plus 6, comma 6 2s are 12 minus of minus 9 plus 9 and therefore minus 3 minus 4. So you'll be getting 0 comma 21 comma minus 7. Proportional values you can take up 0 comma 3 comma minus 1. So 7 3s. Yes, of course, 3 minus 1 option is only C option. Therefore 3 minus 1. 0 3 minus 1 option is C. Yes, of course. This about a few points related with the vector algebra is concerned. And we continue with the three-dimensional coordinate geometry problems. To start with the first one, equation of the plane which is a parallel to this line, plane, equation of the plane parallel to this plane and perpendicular to this one. Parallel to this line and as a line, both are lines given to you. Equation of the plane parallel to this one and is passing through the point 0 1 minus 1. Isn't it 0 1 minus 1 has to satisfy the given equation and also should be perpendicular to these two? That means the equation of the plane parallel to the lines means definitely normal to the plane should be perpendicular to the DRs of the lines. Let me take up here 2 1 4. Of course, dot product with the normals of the DRs of normal to the plane. 7, of course, take up the proportional values 1 plus 2 minus 1. Dot product definitely is at 0. So I hope you'll be getting 2 plus 2 minus 4, it is 0. First one might be the answer. Second one also, if you take up 1 minus 2 minus 1, dot product, I hope you'll be getting 2 minus 2 minus 4, not 0. Second one cannot be the answer. And 1 minus 2, 1. Of course, definitely be not 0 because it is 2 minus 2 plus 4. And third one definitely be not answered. So the answer is the first option. So the answer is the first option. Verification can do it. Coming to the second one. A ray of light passing through the point 1, 2, 3 and strikes the plane. X plus y plus z is equals to 12. A ray of light, touching this line, x plus y plus z. X plus y plus z is equals to 12 and is passing through the point. Which point is that one? 1, 2, 3. This is a point 1, 2, 3 and get reflected and passing through another point. And on reflection passes through 3, 5, 9. 3, 5, 9. And you require to find the coordinates of the B point. Yes, it strikes the point B. This is the point of coordinates. Yes, of course, the point B is a point on the plane. Isn't it one of the options satisfies here? Yes, of course. So 19 plus 7, definitely B, not the first one option. 19 minus 7 could be 7. Of course, 12. This will not satisfy. This also Not satisfying. So the answer is B. So of course it is just B is a point on the plane. It has to satisfy the plane equation. And therefore the answer is a B. Yes. Coming to the next one. The lines whose equations given to you lie in the same plane. The lines are coplanar. The lines are coplanar means the shortest distance or the skews. Shortest distance between these two lines must be 0. Yes, of course. The shortest distance between the two skew lines is 0. So the first line, x minus 2 by 3, x minus 3 by 2, y minus 2 by 3. Third one, z minus 1 by lambda. And of course, this is passing through the point 3, 2, 1. And dr's are nothing but 2, 3, lambda. Of course, this is a B1 and this is A1. Let me take up the second one. Yes, of course, let me take up the point itself here. 2, 3, 2. A2 is equals to 2, 3, 2, the point. And the dr's are given by 3, 2, 3. 3, 2, 3. And let me calculate the shortest distance between them has to be 0 because they lie on the same plane. So determinant, the box product A2 minus A1. So B1 and B2 has to be is equals to 0. And therefore determinant of A2 minus A1 minus 1, 3 minus 2, 1, 2 minus 1, 1. And 2, 3 lambda and 3, 2, 3 determinant is equal 0. Let me expand this one. Along the last column, let me expand. So it is so let me take up here. The points are nothing but 1. So 2, 3 lambda. Let's see that one. Therefore 2, 3, 2, 1. 3, 2, 1. 2 minus 3. Okay, 2 minus 3 minus 1. Yes, of course, this is equals to 0. And expanding along the last column, it is 1 multiplied by. It's a 4 minus 9 minus 5 minus lambda multiplied by minus 2 minus 3 minus 5 plus 3 multiplied by minus 3 minus 5 is equal 0. Minus 5 cancellation, 1 minus lambda plus 3 is equal 0. Lambda is equals to plus 4 you get it. Lambda is equals to plus 4. Once you get lambda, so sine inverse of sine lambda value is equals to how much? So I need to calculate sine inverse of sine 4 is equals to how much? Okay, how much is the value? This value according to the sine inverse of sine x. When you take up the graph, let me take up y is equals to sine inverse of sine x. The graph looks like this one. This is one line and the second line, third line. Of course, these are the lines we'll be getting it. This is y is equals to x line and this passes through the point pi. This is a pi by 2. 1 comes somewhere here and 3 means it is a number. 3 comes here and 4 comes over here. And this straight line is a line which makes an angle 135 degrees with x-axis and this one. And this line equation is y is equals to pi minus x. And that is the same as the sine inverse of sine x. Yes, I need the value of x where x is equals to 4. Why don't you take x is equals to 4 here? Therefore, we'll be getting sine inverse of sine 4 is nothing but pi minus 4. So the required answer is equals to pi minus 4, this particular number. So the answer is equals to pi minus 4. Coming to the next one, the value of lambda such that the 3 planes form a triangular prism. They form a triangular prism means this value should not have a unique solution here. That means the system of equations in this case cannot have a unique solution here. I mean the determinant can never be equals to, and that must be it is nothing but yes, of course, that should not be equal to value. Yes, let me take up this one. So 1 minus 1 1. Yes, the coefficient matrix when you take up here, so 1 minus 1 1 1 1 minus 1 1 1 augmented matrix. Oh, okay, 1 taken right side minus 1. Coming to lambda 3 2 my 3, lambda 3 2 3, and 3 lambda 1 minus 2, 3 lambda 1 and 2. Yes, of course. They form a triangular prism. Triangular prism means, of course, the volume they cannot be 0. That means the system of equations should not have a solution. In this case, this cannot have a solution. Let me take up here. This system can be reduced into the form by operations here. Now, let me keep operation here. R2 minus when you apply the concept to making this element to be 0 and this element to become 0. So let me simplify this as a, so R2 change like R2 minus lambda times R1. R3 change like a R3 minus 3 times of R1. Thereby getting this one as a 1 minus 1, 1 minus 1. So lambda minus lambda 0 and 3 plus lambda, 2 minus lambda, 3 plus lambda, 3 minus 3 0, lambda minus of minus plus 3. So you'll be getting lambda plus 3 and 2, 1 minus 2, 1 minus 3 minus 2, 2 plus 3, 5 we get it. And I'll subtract R3, I'll change like a R3 minus R2, thereby I'll be getting 1 minus 1, 1 minus 1, 0, 3 plus lambda, 2 minus lambda, 3 plus lambda, 0, 0, and here lambda minus 4 and 2 minus lambda. And now suppose in this case lambda is equals to 2 and lambda cannot be equals to 4, for example, when you take up. And this is nothing but a system in the form of Ax is equals to B, wherein this you will have unique solution. This will have unique solution means all the three planes they meet at one point cannot form a prism. Therefore, lambda has to be is equals to 4 here. That must be 0. Lambda has to be is equals to 4 over here. So that condition is nothing but lambda must be equals to 4 to form a prism here. They cannot meet at one point. Coming to the next one, if a line makes an angle 60 degrees, 45 degrees and 45 degrees and theta with the 4 diagonals of a cube, then the value of sine square theta is equals to how much? Yes, let us see that. So you'll be getting, we know in a cube, if any line makes angles alpha, beta, gamma with the diagonals of a cube, you know the formula cos square alpha plus cos square beta plus cos square gamma plus cos square delta, and that must be equals to 4 by 3. We know the concept of it. Cos square alpha, cos square beta plus cos square gamma plus cos square delta is equals to 4 by 3. So where alpha, beta, gamma, delta is given to you, alpha is equals to 60. So therefore cos square 60 plus cos square 45 plus cos square 45 and cos square theta is equals to 4 by 3. And of course, so from here we'll be getting this is 1 plus 1 by 2. I hope we'll be getting 3 by 2 plus cos square theta is equals to 4 by 3. So cos square theta is equals to 4 by 3 minus 3 by 2. We'll be getting minus 1 by 6. Minus 1 by 6. I hope 4 by 3. Hope I'll be getting this one as 1 by 4. I think so. Sorry. I think 1 by 4 plus 1, 5 by 4 this one. Yes, of course. And this is 5 by 4. So 9 minus 15. Yeah, 16 minus 15, I hope we'll be getting 1 by 12, get it. And therefore, sine square theta will be equals to 11 by 12. So the answer is equals to 11 by 12. I hope it is answer supposed to be 11 by 12 only. So 11 by 12. Because it's a cos square theta will be 1 by 12. Okay. Let me take up 6 here. Example 6. Angle between the lines whose direction cosine satisfies the equation. You are given L plus L plus M plus N is equal to 0. L square is equals to M square plus N square. And you know L plus M plus N is equals to 0. L equals to minus M minus N. Square of this is nothing but M plus N whole square is equals to M square plus N square. And this an expansion x square M square plus N square plus 2mn is equals to, it is M square plus N square. Of course, these two are zeros and therefore mn is equals to 0. So either m equals 0 or n equals 0. Suppose m is equals to 0, then L is equals to minus n. You will be getting the drs of one line can be 1, 0, minus 1 you can take up. And n equals 0 when you take up, L is equals to minus m. Drs can be taken it as it is a 1, minus 1 and 0 I can take up. And these are the drs of the two lines, and the cos of angle between them is nothing but a dot b by modulus a modulus b. A dot b is equals to 1 plus 0 divided by root 2, nothing but 1 by 2. Angle between them is equals to pi by 3, 60 degrees. So answer is pi by 3. Coming to the next one. The ratio in which the plane divides the line joining the 2 points. Yes, of course, this is actually the plane given to you. The ratio is minus pi a by minus pi b. The plane equation, if I write this one in the Cartesian form, r dot 1 minus 2, 3. So r dot 1 minus 2, 3 is equals to 17. If I take it as x, y, z, therefore I'll be getting x minus 2y plus 3z is equals to 17, or minus 17 is 0. I name this one as a pi plane. The 2 points are nothing but minus 2, 4, 7, minus 2, 4, 7. This is the first point. And the second point is 3 minus 5, 8. 3 minus 5, 8, the second point. Now clearly you can see that the ratio in which the plane divides the line joining the points. So this is actually the plane which is dividing the line joining the 2 points a comma b. What ratio it is dividing is required to calculate. That's nothing but minus pi a divided by pi b. So what is pi a? That is nothing but substitution of the point a in the plane. So you'll be getting minus 2, minus 8, 21 minus 17 divided by substituting pi b means substituting the b point in the plane. I think it is 3 plus 10, 24 minus 17. So that is equals to, it is minus 17 and minus 8. Yeah, minus 17, minus 25, minus 27, minus 25, 4 will be getting, the value is equals to 6. I hope we'll be getting minus 25. Yes, of course, minus 27. Yeah, 6 will be getting. And the denominator, I think it is 24 plus 3, 27, 37, 20. So that is equals to 3 divided by 10. So 3 is to 10 is the required answer. 3 is to 10. Yes, the answer. Coming to the next one. The equation of the plane through the intersection of the two planes and parallel to the lines y equals to 0 and z equals to 0. Parallel to the lines y equals 0, z equals 0. Y equals to 0 is nothing but y equals 0, z is equals to 0. XY plane. So equation of this one is given by equation of the plane. Let me take up this one. Equation of the plane passing through intersection of the two planes is given by L1 pi 1 plus lambda pi 1. That's nothing but ax plus by plus cz, ax plus by plus cz plus d plus lambda times it is a dash x b dash y, a dash x plus b dash y plus c dash z plus d dash is equal to 0. And that plane is a parallel to y equals to 0, z is equals to 0. Y is equal to 0, z equals 0 is nothing but a parallel to the x-axis. So the plane is this plane whose DRs are a plus lambda a dash, b plus lambda b dash, and c plus lambda c dash. And this plane is parallel to x-axis. Parallel to x-axis means dot product with I is equal to 0. That's nothing but a plus lambda a dash is equal to 0. And that means x coefficient is already 0. So there is no x coefficient and therefore only y will be getting answer is equals to. Yes, of course, it's a mistake here. I hope you'll be getting x coefficient is not 0. Here is also not 0. C option also, I think it is not 0. So answer is none of these. By mistake, I have written down here. I hope we could able to recognize this one. And the C option, there is x coefficient is existing it. And previously also the x coefficient and x coefficient is not there. And therefore, I hope the answer is equals to B. Supposed to be B because A dash value. A dash A, lambda is equals to minus. So lambda is equals to minus A by A dash. When I substitute in the plane equation minus A by A dash, therefore I will be getting A dash into AX plus BY plus CZ plus D minus A multiplied by A dash X plus B dash Y plus C dash Z plus D dash is equal to 0. And therefore this values gets cancelled. A dash B minus A B dash multiplied by Y plus A dash C minus A C dash multiplied by Z and plus A D dash minus A dash D minus A D dash is equals to 0. Yes, of course, A B dash minus A B dash B C dash. Yes, even that also not coinciding with this one. A dash B. A dash C. Yes, of course, this is y coefficient and yes, of course, this one is coinciding with this option. Coinciding with this option, therefore answer is supposed to be B. So the correct answer is a B, exactly coinciding the answer here. It's not D, it is a B would satisfy the required answer, the B. Okay, now let's proceed. Ninth one. A variable plane is at a constant distance 3p from origin and meets the axis in A, B, C, the locus of centroid of the triangle ABC. A plane is intersecting x-axis, y-axis and z-axis at A, B, C, and the plane equation is x by A plus y by B plus z by C is equals to 1. A coordinates A 0, 0 and B coordinates are 0, B 0 and C coordinates are 0, 0, C. The centroid of this triangle is nothing but A by 3, B by 3, C by 3 whose locus need to calculate. I would assume this one as a x1, y1, z1. So that A is equals to 3x1, B is equals to 3y1, C is equals to 3z1. So the plane equation can also be rewritten as x divided by 3x1 plus y divided by 3y1 plus z divided by 3z1 is equals to 1. And the perpendicular distance of the plane, the variable plane is at a distance of 3p from origin. From origin to this one, the perpendicular distance is modulus c divided by under root of a square, 1 by 9 x1 square plus 1 by 9 y1 square plus 1 by 9 z1 square is equals to, how much is the value? It is 3p. Yes, it is 3p. And when you take up the reciprocals, reciprocal here, reciprocal and squaring it. So 1 by 9 x1 square plus 1 by 9 y1 square plus 1 by 9 z1 square is equals to 1 by 9 p square. 9 gets cancelled. You get it 1 by x square plus 1 by y square. The locus is given by 1 by x square, 1 by y square plus 1 by z square is equals to 1 by p square. So the answer is equals to A, 1 by p square. Right, now coming to the next one. If the plane equation contains the line, if the plane equation contains the line, then whose inclination with x-axis whose inclination with x-axis, okay, is 60, it satisfies the condition here. Yes, of course, the line lies on the plane whose direction, of course, the plane is nothing but 3 into x minus 1, x minus 2, y minus 2, plus y minus 2, and 6 times z plus 3 is equals to 0. And of course, the line is given by x minus 2 by a. X minus 2 by a is equals to y minus 2 by b. And that is equals to z plus 3 by 1. Z plus 3 by 1. So the line lies on the plane. Then definitely, yes, lies on the plane means the drs of this one and drs of normal dot product must be 0. So the drs of the normal to the plane are given by 3, 1, 6. Dot product with drs of the line are given by ab1, dot product is 0. So therefore 3a plus b plus 6 is equals to 0. That's one thing. And the line is inclined at an angle 60 degrees with x-axis. And therefore, angle between the line and x-axis is equals to the line drs are AB1, x-axis drs are 100, angle between them is 60. So, you'll be getting cos 60 degrees is equals to A dot 0 plus 0 plus 0 divided by root of A square plus B square plus 1 into root 1. And that is equals to half of it. So, this cross multiplying, you'll be getting squaring a square plus b square plus 1, and that is equals to 4a square. And therefore, we'll be getting 3a square is equals to b square plus 1. The relation. And of course, 3a square is equals to b square plus 1. 3a square is equals to b square from here can be replaced by minus 3a minus 6 taken whole square plus 1. So, an expansion 3a square, and of course that is equal to 9a square plus 36 times of a plus 36 plus 1. So the answer is equals to 6a square plus 36a plus 36 plus 1, 37 is equals to 0. So 6a square plus 36a, 6a square plus 36a plus 37 is equal to 0, first option. Let me take up the next one. The value of m for which the two straight line, value of m for which the line is parallel to the plane. The line is parallel to the plane means, of course, the drs of the line, dot product with the normal drs should be equal to 0. So, the line is given by the two planes, 2 minus 3, 1, 2 minus 3, 1, 3 minus 2. So 3 minus 2, 1, 3 minus 2, 1, and 4 minus 3, 4. 4 minus 3, 4. Their cross product is nothing but gives us the drs of the straight line. Because the line is represented by the two planes, therefore the normal vectors cross product is nothing but actually the drs of the line. So they are given by, I hope you'll be getting minus 8 plus 3. Minus 8 plus 3 minus 5, 4 minus 12 minus 8, and minus 9 plus 6, minus 9 plus 8 minus 1. And these are the drs of the line. And the drs of the plane, 2 minus 1 m. So 2 minus 1 m. So the line is parallel to this one, normal to the plane. Drs are 2 minus 1 m and dot product with these two. This dot product is equal to 0, minus 10 plus 8 minus m is equal to 0. So m is equals to minus 2. So answer m is equals to minus 2. Yes, of course. Coming to one. Next, the equation of the bisector of angle of the planes which do not contain origin. Yes, of course. A plane which do not contain origin is given by the formula pi 1 divided by root of a1 square b1 square c1 square is equals to minus pi 2 divided by root of a2 square plus b2 square plus c2 square, where pi 1 is the first plane, pi 2 is the second plane. So that simplifies the problem, gives us the answer. Pi 1 is nothing but 2x minus y plus z, 2x minus y plus z minus 2 divided by root 6 is equals to minus half x plus 2y minus z, x plus 2y minus z minus 3 divided by root 6. These two gets cancelled, and then simplifying, minus 1 would bring it left hand side, you'll be getting 3x, and minus 2y bring it left hand side plus y, and of course z gets cancelled, you'll be getting plus 3, bring it left hand side, minus 5 is equal 0. So 3x plus y minus 5 is equal 0. 3x plus y minus 5 is equal 0. So answer is D option. Coming to the next one, the equation of the plane through the line of intersection of these two perpendicular to the plane. Line of intersection of these two means nothing but actually pi 1 plus lambda pi 2, and that is a perpendicular to this one, means a dot product with the pi 3 is equal to 0. So 2, 3, 4, first one 2, 3, 4 plus lambda times, of course the dot product means 2, 3, 4, sorry, I hope you have to take up the plane equation, so which is a completely 2, 3, 4 minus 7. So 2, 3, 4 minus 7 plus lambda times of 1, 1, 1 minus 1, 1, 1, 1 minus 1. Of course, we require the DRs 2 plus lambda and 3 plus lambda and 4 plus lambda, and the dot product with the 1 minus 5, 3, 1 minus 5, 3. The DRs of the normal to the third one, and that is equals to 2 plus lambda minus 15 minus 5 lambda plus of course this is a 12 plus 3 lambda, that is equals to 3 plus 1 4 minus lambda, 12 plus 14 minus 1 minus lambda minus 1, and that must be is equals to 0, dot product, because this plane is a perpendicular to the third plane, and therefore lambda is equals to minus 1. So the answer is equals to lambda minus, of course lambda minus 1 means minus 1 you have to substitute here, then you'll be getting the answer is equals to 2 minus 1, 1x will be getting, and 3 minus 1, 2y plus 2y, and 4 minus 1 plus 3z, minus 7 minus of minus plus 1 minus 6 is equal to 0. So 1, 2, 3 minus 6. So the answer is 1, 2, 3 minus 6. Answer is C. Coming to the next one, the plane makes an angle sine inverse A with x-axis, then the value of A. Yes, the angle made by the plane with x-axis is given by. So the angle made by the line with x-axis, 2 minus 3 is 6. Yeah, 2x minus 3y plus 6z is equals to 11. Yes, of course. And let me simplify, converting this one into the normal form. Let me divide 2, 3, 6, the value under root of 4 plus 9 plus 36, the DRs, when you take up, and then converting in terms of DCs, dividing by 7, 2 by 7x minus 3 by 7y plus 6 by 7 times of z is equals to 11 by 7. This is Lx plus My plus Nz is equals to D. And therefore, the angle made by the plane, the normal to the plane with x-axis is nothing but actually cos inverse of 2 by 7. Therefore, cos alpha is equals to 2 by 7. But here you are given the plane equation. The plane equation means definitely sine alpha must be equals to 2 by 7. Because the normal to the plane, okay, will be making an angle, the other one as 2 by 7. So the answer is equals to sine alpha is equals to 2 by 7. So 2 by 7, and therefore the value of A is nothing but sine inverse of this value. So 2 by 7 is the required answer. Coming to the next one, the shortest distance between the two skew lines. Of course, it is a direct formula. So let me take up the point on the line. A point on the line is 383. Okay, 383. A point on the second line now. So minus 3, minus 7, 6. Minus 3, minus 7, 6. And the DRs of the first one, 3 minus 1, 1. So 3 minus 1, 1. And DRs of the second one, minus 3, 2, 4. So minus 3, 2, 4. The shortest distance we can calculate by the formula directly. It is nothing but A2 minus A1, B1, B2, the box product modulus divided by B1 cross B2 modulus. And therefore, that we calculate by this way, determinant A2 minus A1. I hope we'll be getting 6, 15, minus 3, 3, minus 1, 1, minus 3, 2, 4. Determinant. Let me calculate the numerator first, or divided by the modulus of, yes, of course, this cross product of these two vectors. Okay, let me simplify this one. That is equals to 6 multiplied by minus 4, minus 2, minus 6, minus 15 multiplied by, I think, 12 plus 3, 15, minus 3 multiplied by 6, minus 3, 3. Yes, of course, 36 minus... minus 36 minus 225 minus 9. So minus 45, 225, 45 will be getting 270, minus 270. Of course, numerically we take up the modulus value. And the cross product is nothing but the cross product of these two values. Let me take up here cross product 3 minus 1, 2. 3 minus 1, 1, minus 3, 2, 4, minus 3, 2, 4. The cross product B1 cross B2 is equals to, I hope, minus 4, minus 2. Yeah, minus 4, minus 2, minus 6. Yes, of course, minus 6. And minus 3, minus 3, minus 12, minus 15. And 6, minus 3, and minus 3. Yes, of course, plus 3. And the magnitude of B1 cross B2, of course, it is 36 plus 225 and plus 9. Of course, same as like this one, root 270. Numerator is 270, denominator and root 270. Therefore, shortest distance is nothing but 270 by root 270. That is equals to under root 270. 9 taken common. So 30, 9. Yes, of course. 90 when you take out common. So 9 means 3 root 30. Yes. So the answer is equals to 3 root 30. Yes, of course, the option answer. So I hope we have done enough sums for 3-dimensional coordinate geometry also. Okay. Practice more sums to get the score and grip on the subject. I conclude this today's lecture with this one. Thank you.